everyone, I'm Hannah Jasmine Santos and welcome back to my YouTube channel. So for today's video, we will now go to the experiment number 10, which is about the multivibrators and SR flip-flop. The set-reset flip-flop is commonly known as SR flip-flop, and the two output states are meant to be complementary. The terms set and reset may be taught that set to 1 and reset to 0. Notice that the circuit is actually symmetrical. The input labels may be interchanged as long as the output labels are also interchanged. This SR flip-flop has only two valid inputs, 0, 1 and 1, 0. When both inputs are 0, the output is unaffected. This means that there will be no change in the output. On the other hand, when both inputs are 1, the output is indeterminate or unpredictable. To make this a simple memory device, a clock or gate input may be added as shown. In this case, the outputs will change state only when the gate input is high. If a new set of valid signals is fed to the inputs, no change will occur in the output if the gate input is low. However, as soon as the gate signal goes high, the output changes to reflect the condition of the inputs. Our materials in this experiment number 10 is first is our power supply. Next is our breadboard, our SPDT switch, also the LED, our IC which is 74LS00, that is a NAND gate, and our jumper wires, and lastly our alligator clip. So let's start interconnect the circuit in this experiment number 10. Let's open our jumper wire. So in our breadboard, let's place first our IC. In putting IC on the breadboard, we need to be careful. Okay, then you can see in the circuit in our figure that there are two input, which is D1 and D2. D1 is our S and D2 is our R, and there are four output, which is in 1, in 2, in 3, in 4. That will be our LED. So the 1 and 2 of this IC, the NAND gate, is connected. I have here a little one that suit to this one. I need to push this. Okay. Then also the 4 and 5 is connected. So 1, 2, 3, 4, 5. So let's place the switch in the breadboard. The other one. So this switch is our D1 and the second one is our D2. So in the figure, the 1 and 2 of the IC is connected to the D1. So we will connect this to the center of the switch. And for the D2, we will connect the number 4 and 5. Okay, so the number 3 of our IC is connected to the number 12. So let's connect the number 3 of our IC to the number 12, which is this side, in this side. So let's use this jumper wire. This is the number 14, 13, and 12. And the number 13 is connected to the number 8. So this is our 13. And our number 8 is here. The number 6 is connected to the number 10. So our number 6 is here. 1, 2, 3, 4, 5, and 6. This one. And it is connected to the number 10. So this is 8, 9, 10. And the number 9 is connected to the number 11. So this is 8, 9, 10, 11. This one and this one. So we will use So now the number 9 and number 11 is now connected. So let's check. Number 1, number 2 is connected to the D1. Number 4 and 5 is connected to the D2. Number 3 is connected to the number 12, which is the green one. And number 6 is connected to the number 10. The number 13 14, 13. The number 13 is connected to the number 8, which is this gray. And the number 9 is connected to the number 11. So let's put our LED. So our LED is connected to the D1 and 1 and 2 of the IC. So let's put the LED here, and we will connect the 1 and 2 of the IC to the LED. And the number 4 and 5 of the IC is connected to the in2. So we will connect the positive side of our LED to the number 4 and 5 of the IC. And the in3 is connected to the number 11. So we will place it here, and the number 11, this is 8, 9, 10, 11 is this one. And other one, the in4, it is connected to the number 8. Which is 7, 8, this one. So the negative side of our LED is connected to the negative side of our breadboard, which is our ground. So we will connect this. So this is the negative side of our LED. The other one, our in3. And our in 1 and in 2 is also connected to the negative. Okay? So, next is, we will adjust this one. And number 7 of our IC, we will connect it to the ground. And number 14, we will connect it to the positive side of our breadboard. So this is the number 7. Okay. Then also the number 14. So this one. And also our switch, we will connect this to the negative side and to the positive side. So I will put it here, and we will connect it to the positive side of our breadboard, and also the other switch. I will connect this jumper wire to this pin, and I will connect it to the positive. And in this side, the last pin in here in the right side, I will connect it to the negative side of our breadboard. And after that, we will connect our circuit to the power supply. So and also the other switch. So let's check our figure. So 1 and 2 is connected and connected to D1. 4 and 5 also connected to the D2. Number 3 and 12 which is this green, number 6 and 10, which is this black, number 13 and 11, so that is 8, 9, 10, 11. So let's place this one for our alligator clip, which is this is for the positive and this is for the negative. And we will connect now our alligator clip in our power supply to our breadboard. So our D1 and D2 is now at logic 0, which is this side, which is point to the right side. So let's open our power supply and see what happened. So let's turn on our power supply. So our D1 and D2 is at logic 0. So in the switch, this is in 1, in 2, in 3, and in 4. So when the D1 and D2 is at logic 0, the only at logic 1 is the in 3. And when we turn on our D2, in 1 is at logic 0 and our in 2 is at logic 1. And in 3 is at logic 0, our in 4 is at logic 1. So in 2 and in 4 is at logic 1 when D2 is turned on, while D1 is turned off. And when we turn on the D1 and we will turn off the D2, we will make the D2 at logic 0 and we will make the D1 at logic 1. What happened here is our in 1 and in 3 is at logic 1, while our in 2 and in 4 is at logic 0. So next, we will make the D1 and D2 at logic 1. So the two switch is both turned on. So you can see that the 4 LED, the in 1, in 2, in 3, in 4 is now at logic 1. So now let's proceed in our second figure. So in our next figure, there is 3 input. So we will add D3. So in this circuit, the 1 and 2 connection of the IC is changed, also the 4 and 5, but the other side, which is the number 12, 13, 9, 10, 11, 8, and also the in 3, in 4 is still the same. So we will adjust the connection in the in this side where is the number 1 and number 2. We will remove it first so we can get this little one, and we will back the green one in the number 3 of our IC. And in that case, the number 1 of our IC is connected to the D1. So this is our D1, and we will connect it in the number 1 of our IC, while the number 2 is connected to the D3 and also the number 4. So here is the number 2 and the number 4. So we will use this one. And now we will add our D3 here, our third switch. We will place it, I think, here. Okay, then our connection of 2 and 4 is connected in our D3. Okay, and the number 5 is connected in our D2, so we will connect this D2 to number 5. So it is here. But now I see that the connection wire here is in 2 and in number 5. So we will adjust this to the 2 and 4. So now it is in number 2 and number 4. So we will place back the number 2 here, and the D2 is connected in our number 5. So here, then our in1 is connected to the number 1 of our IC. So our in1 here is this white again. We will connect it in the number 1. So here, and our in2 is connected to D2, which is connected to the number 5 of our IC. So our D2 is this red jumper wire. We will find the D2. This is the D2 that is connected to number 5, which is this number 5, the white one. So we will place it beside the white jumper wire. Okay. Then for the third switch, the D3, we will connect it to the negative and positive side of our breadboard. And also this side to the positive. So I will use this. So okay, I will put it here. So, and put it in the positive side of our breadboard. So let's check. Let's check now if the connection is exact what is in the figure, if it is correct. So D1 is connected to our IC, number 1 of our IC, and D2 is connected to the number 5. Okay, 1, 2, 3, 4, 5. Then the number 2 and number 4 is connected, which is also connected to our D3, and the number 3 is connected to the number 12. So the connection on that side is still the same. So we will now connect this in our power supply, and let's see what will happen. So our D1 D2 and D3 is at logic 0. So let's see what will happen when we turn on our power supply. You can see that only in3 is at logic 1, while the rest is at logic 0. So what will happen when we make D3 at logic 1? So it is the same, only in3 is at logic 1. So next we will make this at logic 0. So we will turn on the D2. So you can see that now the in2 and in3 is at logic 1. So what will happen when we make D3 at logic 1? What happened here is the in3 is now turned off and our in4 is now at logic 1. So next, we will make D1 at logic 1 while D2 and D3 is at logic 0. So what happened here is in 1 and in 4 is now at logic 1, and we will make D3 at logic 1 again, and now the in3 becomes at logic 1 while in4 is at logic 0. And for the last we will make D1, D2 at logic 1 while D3 is at logic 0. So we will make D2 at logic 1. So you can see here that in 1 and in 2 is now at logic 1, also the in 3, and the only one at logic 0 is the in 4. And when we make D3 at logic 1, so all of our switch is now at logic 1, what will happen is all of our LED or our output will now at logic 1. Our in 3 now and in 4 is both at logic 1. They are both turned on, also the in 1 and in 2. So that it is for our truth table. So that's all for today. I hope you learned something new about this experiment number 10, multivibrators and SR flip-flop. Don't forget to subscribe and like this video. Thank you!